We are on Module 4, and Module 4 we're going to be exploring atmospheric pressure and wind. In the last unit we introduced wind as advection, and in that unit we also indicated that there was pressure differentials in the atmosphere at certain locations, namely the equator and in and around the equator at the poles, and then in between at 30 degrees latitude and 60 degrees latitude are where some of the global big pressure belts are. The difference between high pressure zones and low pressure zones are what's going to create advection or wind, and that's what we're going to explore here this unit. So air pressure then is when a force is exerted on an object by gas molecules. So those gas molecules are going to move into an area and apply pressure to that area from all directions. So this is three-dimensionally. It's not unilinear where it's from point A to point B, but in multiple directions that air pressure is exerted. So air pressure then is manifest through three different modes: density, how much space there is, and how much motion there is in those gas molecules. So we've all been in an environment where the room is really packed and there's a lot of density in there and it's really hard to move around. And particularly if people are energetic, then there's going to be a lot of pressure. People are going to be jostling around and trying to get past each other. This is the same scenario with the atmosphere. If there's a lot of molecules and a lot of mass in a location, then the pressure is going to be high. When the molecules of gas are removed or lower in volume, the volume of pressure is going to be less. So if you recall from our first units when we were talking about atmosphere and we were talking about atmospheric profile, we said at the lowest level of the atmosphere, if you take a look at this little slide right here, the lowest level of the environment, we've got lots and lots of molecules, which means the pressure is going to be greatest here. Here we're showing it at sea level, so we're going to have high pressure here at sea level. And as you ascend into the atmosphere, the volume of matter in the atmosphere diminishes, so the pressure becomes less as you move up in elevation. We get differential amounts of matter across the surface of the Earth as well. So we could have a lot of molecules over here and fewer molecules over here. So this location will have a higher pressure than this location if that were the case. The size of the space is going to determine how much how much pressure there's going to be as well. If you keep the volume of molecules static, let's say we've got 10,000 particles of air or molecules in the atmosphere of air, and we have a large space, all of those molecules can spread out. They're going to be buoyant, and there's going to be low pressure in that environment. As the volume of the room becomes smaller, then the pressure becomes greater. So small areas generally have high pressure. Large areas generally have lower pressure. So think mountain environments where the valleys are nice and tight. The pressure may be higher there than if you're out in Kansas, where you can go on for miles and there's really no landscape change. So we've got lots of volume, which means much less pressure as a result. And then motion. The faster an object is moving, the higher the pressure is going to be. So if we've got an energetic atmosphere because there's a lot of solar energy coming in, and that happens to be in a dense environment where there's a lot of molecules, the pressure is going to go up even higher because those molecules are really pushing against each other. So instead of a dense space where a lot of people are packed in together, perhaps in a traditional room where you're testing, there might be a lot of pressure because you're taking a test, but there's not a lot of physical pressure in that room, as opposed to having those same number of people in that same space, and you put on some good music and everybody's dancing, and people are going to start to bump into each other, and then the physical pressure starts to increase. If the walls start coming in on that dance floor, then the space becomes constricted and the pressure goes up even more. So density, size, and motion all play into to how much pressure there is. We could have a high volume of motion and a lot of space, which means maybe the pressure scenario there is going to be somewhat moderate. Or if the pressure, or pardon me, the density is low and the space is large, then we're going to have really low volume of pressure in that area. So we can take a look at these three variables and combine them to result in various pressure conditions. And air pressure changes moment to moment for any individual location based on the changing conditions that are a factor of the incoming solar radiation, the time of day it is, the amount of particles that are in the atmosphere, and a number of other secondary and tertiary variables.